So this is a heating curve. A heating curve is going to be different from the phase diagram, mostly because of the x and y axes. So if you look, a phase diagram, if you remember, was pressure versus temperature. This one is going to be temperature versus time. Temperature is on the y, time is on the x. So it's actually telling you how long these substances are in the different phases. This is a heating curve because notice the heat is rising. There's also something called a cooling curve where it just goes the opposite way, the temperature is going down. So for this heating curve, you are going to have to know where the transitionings are happening and where the phase is actually in a phase. So when you start with a heating curve all the way at the bottom, the lowest temperature is always going to be the solid, and the phase is actually the increase. Most kids think that the phase is going to be right here on the horizontal. No, it's actually on the increase. So that's where the solid is. The liquid's always the next one up. And then the gas is the top one. So where it's actually increasing is where it's in the phase. The horizontal is actually where it is changing. So it's a little bit counterintuitive, but if you think about it, remember when it changes from a liquid to a solid, or solid to a liquid, the temperature doesn't change because all the particles are getting all that kinetic energy. So the temperature actually stays constant throughout the whole change, and then it starts to increase again when the substance is in that phase. So the first question, in what part of the curve would substance X have a definite shape and definite volume? So this is asking you actually a couple questions. First, do you understand what phase is a definite shape and definite volume? And you're going to remember, yes, you do know that. That is a solid. So you're going to know, because you could label it if you want, that the solid is always the first increase. So that would be part of the curve 1. Notice they're labeled in this particular curve with 1s, 2s, 3s. So it's easier to answer. The next one, in what part of the curve would substance X have no definite shape or volume? So again, it's asking, do you know the characteristics of the phase? No definite shape or volume would be a gas up here. So that is going to be section 5. Okay. What part of the curve represents a mixed solid-liquid phase? So if we said, okay, here's where it's all solid, here's where it's all liquid, where are they mixed? It's actually while it's melting here at part 2. So if you think about a piece of ice cube melting very quickly, you'll know that you actually have liquid present and solid. As the ice cube melts, you actually have both phases present. What is the boiling point of substance X? So again, boiling you have to know is when you go from a liquid state to a vapor or a gaseous state. So here's where it's liquid totally. Here's where it's gas totally. Where the change is happening is this horizontal. So this is asking not where is that change happening, it's asking what the boiling point is. Boiling point, remember, is a temperature. So this time it's asking where is the boiling point? What is the temperature of the boiling point? So if it's boiling right here on segment 4, I'm just going to trace over and figure out that the boiling point is going to be 55 degrees Celsius. So you can do that for any of the phase changes, boiling, melting, etc. The next 2 questions are a little bit of a challenge question just to see if you remember the concept of potential and kinetic energy in the phases. So it says, in what part of the curve would the potential energy be increasing? Where are things kind of ramping up, if you want to think about that? And that would be where the transitions are occurring in 2 and 4. Where would the molecules of X have the greatest kinetic energy? Remember, kinetic energy is movement energy. And if you remember, the phase with the greatest or fastest moving particles is the gas phase. So that would be segment 5.